And you already learned in the civil engineering material class with Dr. V, you know the concrete, the quality of concrete can not only be determined about the quality of aggregate, the quality of the cement, the quality of the water, the quality of the curing concrete, handling of concrete during the placement and afterward. It also very important to ensure the quality of concrete is meeting the intended designs that set by the engineers. So in the next few slides, I will show you the correct and incorrect method of handling concrete. And then we will talk about the expansion joint, the typical how they use, and how to place concrete underwater. And that is the purpose for this lesson video. So let's go through the what are the correct and incorrect method of handling concrete. And as you can see, uh, the right here, incorrect, and the left finger that you see correct one. So the difference between here when you direct the place concrete, and you can see on the right side incorrect. If you put nothing, just only the chute that way and no on the other side, then it you can see the rocks with the coarse aggregate. It tend to be located far left, and that make a segregation of concrete. So the concrete will not be homogeneous, as you can see there. Then how to deal with that? As you can see, we may use the counterweighted rubber scraper if it's far away. And in the chute, as you can see there, you can have the both sides so that when it concrete going down, it can be distributed truly, so it avoid segregation. And it also, if it's more vertical, then okay, we can go the belt or the chute, and then we need to have the headroom, the pipe, down pipe, both sides, so that the concrete go and distribute homogeneously in the areas. And when you place the drop the concrete, we have to drop in the middle, not in one side, because one side tend to segregate the concrete, as you can see there. Or if we use the set divide hooper for two weight, and if we don't use, as you can see, the opening that narrow double gate, so that the concrete will distribute in both sides of the hooper, compared to just directly put it in there, leave it alone, then the rock tend to be go to the right and the mortar go to the left, and the quality will not be homogeneous. And then to discharge the hooper for loaded buggies, and you can see the buggy there, and it have to be go vertical drop instead of just one side, and you can see it will get the segregation. And similar to here, as you can see, if you have the pipe, the down pipe have to go vertical. On the other side, if you go yes or without the baffle, it's also not correct. If you have baffle, it have the segregation, rock tend to be and mortar tend to be segregated. And same for this one, and you can see the key between this, you see the down pipe to ensure no separation. If you only have the baffle in this way, or no baffle at all, both will have segregation of and separation of the mortar and the coarse aggregate, as you can see there. To place the concrete in the narrow form, just like the wall or the columns, you cannot, for example, this is chute and buggy method, you cannot just place directly to face to the form, concrete form. We will talk about that in the next few lessons. And just directly and going down, and as you can see, it will get the segregate. What people do, we need to chute, go direct down so that it will be go to the below, so it cannot drop too high from the top. And with the chute here, it can be say that, as you can see, if you place directly to the form or to the rebar will get some dirty of the concrete before we place concrete. If we have a chute here, it can maintain the clean rebar before the concrete go to place in that areas. And if you place in the same for the narrow form, and in case the that structure is height, like a go or column, we may have an opening uh, to reduce the effective height of placing concrete, because we drop the concrete too high, it will get segregation. But when you make that opening, the left side show you the correct way to do compared to the other side, it tend to be more segregation in there. And instead of place the concrete, you have to place the concrete from the previously placed concrete going back, cannot go far away from the concrete placing, just shown it on the right. And same for here, when you have a chute, the direction of spreading both go to the left, then as you can see there, the orientation of the chute have to be maintained in correct way as shown in the left, so that it avoids segregation. If you go this direction left but the orientation set that way, then you have a separation of the rock and the mortar as shown on the right. Lastly, when you place concrete on the slope, then play here you have a baffle to avoid separation, just not place the chute directly to that slope of concrete. And then now go to the consolidating of concrete. With concrete we place, we need to have vibrating to make a consolidation to avoid honeycomb, void, etc. So in this slide show you what are the correct way to do. First, when you place the on the slope, we need to start at the bottom of slope going up, cannot the other way around as shown in here. When you penetrate the vibrator into the concrete, it may have a few inches go to the old concrete, so that we have the bonding between the current lift of the concrete to the previous lift of the concrete, and cannot be randomly placed the vibration anywhere. It will create additional separation of the mortar and rock as shown in the far left far right finger that's shown here. And of course concrete can be placed underwater, like boring. You study the foundation construction, and I show you different deep foundation. One of them like diaphragm wall or bore pipe is all required placing concrete underwater. And as you can see, this is the tremie used to put the concrete down, and it always maintain the opening of the tremie. It go deep into the concrete so that the water will not get in, so you can place concrete properly with the water surrounding. And now go to the expansion joint. Concrete, it's easy to crack, as you can see. How to avoid joint, we avoid the crack, we use expansion and isolation joint. And show you a few ways. You have caulking between the wall and the slab. If the slab is long, you can be able to make the expansion joint and have a dowel to connect between them. And of course, we can seal with the mastic, etc. If it's heavy duty, we slab we can do in the bottom finger that show you in here. And then we have control joint, just like your driveway, etc. We may make a shortcut or group cut, as you can see there. So if we crack it, crack down there, but we don't see it, so we feel more pleasant with the slab. And of course, if we need to have completely control joint, then we can use the angles standard shape of the steel and anchor it into the concrete, so that we can maintain the smoothness of the surface while we still maintain the control joint on the slab. And if we put under the water the concrete here for the water, we may need to use the water stop. There are a few ways that you do. So the first one, as you can see, to place the concrete, and the other side it going to place concrete. You put the mantle, put it down, and this is the bucket So place concrete. After we remove this, we will bend that corrugated metal out and place the concrete in the next segment so that they bond together. The water will not intrude because there is a metal prevent the water go through. The other is water stop. It made by PVC plastic, and you can see there. So the bulkhead, you see concrete on the left, concrete on the other side, and then as you can see, with that the water will not go because the PVC, and that's why they call water stop. It stop water go through. Normally apply in the tank, water tank, concrete, etc. And if the water stop can be do in the middle, as you can see there. With that, we stop of the concept of practices of construction. In the next video, you will learn the how to determine the rate of placement of concrete, because that important when we move on to the next few lesson, when we determine the concrete pressure, because that will affect how we design the formwork. So the rate of placement of concrete, that will be in problem 2 and 3 in today's lessons.